I'm going to be talking quite fast, so please interrupt me, ask whatever you want to ask whenever, and I'll just not reply because I have no time for questions. So without further ado, let's go forward. I need that thingy. Which thingy? This thingy. Thingy on. Thingy works. Cool. So I'm Sakari. I'm an Azure MVP. I've been coding .NET professionally since 2001 and Azure Platform as a Service since 2011. I'm the founder and CEO of Composer and the founder of Finland Azure User Group and also an organizer here. That's about me. The presentation, I'm going to talk a couple of slides first about IoT solutions in general. And then we are going to dive into this stack of tools that Azure offers on how you can build these projects and how do these tools overlap and which should you choose in whatever case. And then we are going to dive into some hotspots, some troubling places that most teams encounter when they try to build something IoT-like. IoT. In my mind, I don't know if I'm alone, but it seems that IoT as a theme is very highly hyped, and it has somehow gained this mythological status amongst developers. So how many of you guys have developed something you deem IoT? So a couple of hands, less than half, let's say 30%. And how many of you are familiar with APIs or web apps or regular databases? Hands up. So that's all. And what I've started thinking is that people who are familiar with web apps and regular, three-tier architecture and all of that, they might feel that IoT is something that's kind of magical. It's out there. There's something weird about it. And in this talk, I want to bridge that gap. I want to show that there's nothing special about it. You don't need to be a rocket scientist or anything like that. And it's just about some different types of data, some different type of ingestion, how you receive the data, how you process the data. There are a couple of new tools, and that's it. So nobody should be worried that, when you're talking about a custom development project or a custom IoT project, they shouldn't be thinking that, oh my God, this custom IoT project is a lot more difficult than this custom project, something else. Because the issues aren't with the technology per se, it's always about the domain. Let's get back to that on the trouble hotspots. This is the regular. Sure, you have sensors in the rocket, but this is the regular thing you'll be working with on IoT projects. I took this from the internet. I don't know what that machine is. I don't know what it does, but it looks very manufacturing. So it's probably on some installation or site or plant or whatnot somewhere. And it has a huge configuration panel. It has probably a lot of sensors. Does it send data outside of it, IoT style to cloud or somewhere? I don't know, but it might, because I guarantee you there's a team of maintenance people. That might be maintained by internal people for the factory, or it might be maintained by the vendor, the creator of the machine, the builder of the machine, manufacturer of the machine. And they are, because the world is going to a direction where even bigger companies don't want to just manufacture, they want to give service. And since the service quality needs to be high, they are interested right now in this world about what's happening, what is the state of that machine. So in real life, that machine sends something or it doesn't, but there are sensors about pressure, about temperature, about electric things like volts and amps. I don't know, electrical power, I said yesterday, and someone laughed. And there are also alerts. So we have this continuous telemetry, like temperature. Good example, because we all feel it. It's continuous, it keeps on coming. And then we have these singular events, discrete events, like someone flicked a switch, the light went on. Someone flicked a switch, the light was supposed to went on, but it didn't, so it's broke. So there's another alert. So there are two types of data we are working with when we are talking about IoT projects. And personally, to me, that is the biggest thing to keep in mind. The thing that we have this continuous time series of data we can aggregate, and then we have these events, true, false, something else. So when we get to designing an IoT architecture, what are the themes, what are the topics we need to think about? First off, like in every project, we got to think about the purpose. Here we're thinking about the data purpose. Apps. Is it going to be an app somewhere for the customer, for the maintenance people, for the service manager, for whoever, some kind of app that gives you the state of that machine you just saw? Is it broken? Is it working? When was it available? All of that stuff. Mobile apps, web apps, whatever. Process automation. So we get data from that machine that some value is above some control value. So, there should be, the temperature of this thing should be below 40, it's 41. So how should we manage the rest of the process in the factory? So this sensor will be an input to other devices, and the other devices will change their way of working accordingly so that the whole of factory works smoothly. Reporting. We got a lot of data. Let's draw a diagram. Machine learning. The familiar example, of course, is predictive maintenance. Basically, we have machine A that sends data, and then it broke down. Machine learning can distinguish between this pattern and reveal the pattern that led to this breakdown. And when machine B gets the same kind of pattern, or it's closing up to the pattern of values that machine A had, then machine learning can say, hey guys, this pattern is 80% match. It might be that it's going to break soon. So that's the thing. And then we have archive. Sure. Some companies would be just, okay, let's put sensors there, let's send data. We don't know what to do with the data yet. Let's just archive it. And I think that's a smart approach. It sounds like a mellow one from all of these, but when you think about it, it's very hard to envision or innovate something when you don't have any inkling of the tools or anything. But if you have the data here at your hands, maybe you get new ideas. So archiving something isn't a dumb idea. It's just the top of the next hill. Device management. You have devices that send data, big, small, they be fridges or manufacturing plant things or whatever, but you have those, and do you need to manage those devices specifically? That's a question for the architecture. Or is it good enough that, hey, I'm just like receiving a lot of data from somewhere? Or do you need to have device-specific security and all of that stuff? Data type, this we spoke about already. Is it continuous or is it discrete? Most often it's both. And there are different tools to manage those. Data transfer, the last box. Is it chatty? Is the device sending lots of small packets of data? Or is it sending large packets of data that have multiple messages inside? Or is it sending multi-parts? Like, we got 18 messages, there's a correlation ID inside, we got to put these together. And then other files, other binary data. If you have an answer to all of these, then you can design the IoT pipeline. And sure, I'm talking about Azure, but these are pretty agnostic, right? So let's jump into IoT pipeline. On the left, we have a machine, and there on the right we have a web app. So this is the case where we want to show the state of the machine on a web app. And you're very familiar on doing web app, like I asked you, and you know what that is. And now we need to bridge this gap. What do we do? So beneath web, we usually have API, sure. And then we have, oh my God, don't go there yet. Then we have hot storage. So, Redis cache or whatever, some kind of storage that responds quickly to HTTP requests. But then how do we get the data from the device to this storage in a way that's common or good or domain approved for the business case web app there? Ingestion is first step. We need to get those events, those messages inside. And Azure has two tools, IoT Hub and Event Hubs. We're going to look at those differences soon, but the biggest difference is that IoT Hub is bi-directional and device-specific. And Event Hubs is just, give it to me, give it all to me. Then we're going to process those. In pretty much all cases, there's some kind of processing immediately when the event is received. Routing at the least, but usually when there are a lot of events, And in these kind of cases, like 100,000 messages a day is kind of the minimum, basically. If you are like, even if you only have a couple of devices that are not like toilet paper holders or something, you are getting like 100,000 messages a day. So that's a good baseline. So some millions of messages a month is a good estimate for even the smallest of IoT projects. So you process them somehow. You aggregate, you put like, if you get 100 values per second, maybe you aggregate that on a second level or a minute level so that you only have one, and then you do analysis on that and all of that kind of stuff. And then you persist. You have some layer of databases, data storages that you use beneath the hot storage of your web app. And there we have the planet scale Cosmos DB, the storage blob, and the kind of new thing, Azure Data Lake. Cool. We're going to look at the ingestion first. IoT Hub, Event Hubs. And I'm going to start with this not at all data-heavy table, because this is a great example of how clear the difference here is. I think Microsoft has done a great job in defining what is the purpose of these two tools. It's not that case with every Azure product, like you well know. Like, there are lots of products and you're like, oh my God, what's the difference with this? And you really got to do something to know it. But these are pretty clear. If you look at it, IoT Hub, two-way. You can message the device from the cloud. That's clear. Protocols, no, well, there's a bit more in IoT Hub, but both have a good spread of standard protocols. But device identity, device-specific events in IoT Hub. Once again, there's like certificate-based security on if you deploy a device, you have a device somewhere, there's a certificate-based security on the messages from the device to IoT Hub that lets you know that there hasn't been tampering on the way. And there aren't that many competing products on the world for this kind of foolproof security, so to say. It scales high, there's file support and there's routing. So basically IoT Hub gets the message, it can route to multiple places like service bus. Funnily enough, it can't route to Azure function. So that's kind of bummer. I guess that's the word I had to go through many words until I found one that's not a curse word. Okay, and Event Hubs is just getting lots of events, both. Microsoft says that both are millions of events per second, sure, but Event Hubs is like 1/4 the price, basically, because the pricing is different. IoT Hub is per message, and the lowest tier is 42 euros, 280 messages per minute, and Event Hubs is per ingress bandwidth, basically, 1 megabyte per second for 20 euros a month. So with 100 kilobyte messages, that's 26 million messages a month, while IoT Hub is getting 12 million messages with that rate, and the price is halved. So 4 times the oomph on the cost effectiveness of Event Hubs. Capture is a feature on Event Hubs that lets the Event Hubs store everything it receives into data lake or storage blob direct, meaning that you don't need service bus or anything else. It just stores everything you receive. It's a good way to be sure that, hey, we got it all. That's 60 credits a month. So not that crazy cheap. So where would we choose whatever? We choose IoT Hub when we need control. It's bi-directional. It has device state and management. It has device-specific security, and it has routing. So there are a lot of nice features. Event Hubs when you just need the data in the cloud. Performance is higher, meaning that, okay, if you have unlimited amount of funds, both have a very high performance, because you can just call Microsoft, get me a data center, and they'll build it to you. But since you probably don't have unlimited amount of funds, then Event Hubs, you start there, and when you need something bigger, you go IoT Hub. It's partition-based. So IoT Hub is device-based, and this is partition-based, meaning that a device sends data to partitions defined within Event Hub. And those partitions are the key to scalability of Event Hub, meaning that you're going to have like many partitions, and if you don't force a device to send to a defined partition, it round robins and sends to all of them. So that means that the the throughput of partitions stays the same and all devices send all their data into partitions. You can also define that device here sends only to partition 1. Then the other side of the equation is consumer group. So within Event Hubs, there are consumer groups to which you define which partitions these consumer groups are listening to. Meaning that there's group 1 that listens to both partitions and there's group 2 that also listens to both partitions. So we have 2 consumers, one is some app and one is some Azure function, and they both receive all of the events sent to Event Hub. So consumer groups make the distinction between who gets the event and who doesn't. Let's jump to the storage wars. Now, I'm going to show you the process last because that's going to be the newest part to most of you. And I'm going to show a bit of demo after talking about these storage definitions. So here we have the storage wars. Cosmos DB, Storage Blob, and Azure Data Lake. And this is the best storage wars. This is better than the other storage wars. The Texas one is, that I don't like that, but this is good. I'm not sure if that's in TV anymore. So now it's an awkward place to have this stop working. I was too long on that slide. So Azure Storage, very familiar to most of you. How many of you are familiar with Azure Storage? Is it like pretty much most of you? That's like, because that was the first thing that Azure basically had, cloud services and Azure Storage. So cheap storage for raw data and table storage, because usually we store raw data in blob storage, but table storage, it's a good place if you have some kind of aggregate data and you don't need to query that data by multiple dimensions. Basically, if you just have, okay, this is the aggregate result, we need that, let's query for that, and if you need some indexing, then you can have a separate index table. But table storage is great if you know that there is only one way to ask for this data. But once you get to a point that you really need to build a web app on top of it, and there are like accounts and employees and everything, and the data is very relational, then table storage just don't go there. We tried to go there once. It's like you know, everyone is shooting themselves in the heads. So Azure Data Lake, the newcomer, raw data at a massive scale. So Azure Storage can store a file up to like a bit less than 5 terabytes. And Azure Data Lake doesn't have that limitation, since what it does, it does in a distributed fashion. You store a huge file, like 10 terabytes, into Azure Data Lake. It stores those really in tens or hundreds locations, and when you read it, it reads from those simultaneously or parallelly. So there's no limitation on size on Azure Data Lake. It's also a great analytics source because it's natively HDFS, so that's Hadoop's, the big data analytics tools, native file system. And there's also, we are talking about Azure Data Lake Store here. There's also another product under Azure Data Lake umbrella, Azure Data Lake Analytics, which is just like Hadoop, but you control and code that with USQL, SQL-like language that has C#-like elements. And then there's POSIX permissions. And this is basically, those other things are great, sure, but I think this is the biggest reason I've seen bigger organizations, here in Finland at least, moving to Azure Data Lake, because you can define, the structure there is folder-based in Data Lake, so you can define read, write, execute to folder and all of its children, and specific items, meaning files as well. And that's probably because Azure Storage has these shared access tokens, and there it's you can't do the same things. Sure, in some cases it's awesome to be able to give a key that's an access to data, so Azure Storage isn't being eaten by Data Lake, but still for big companies who have issues with data access, you know how they have sensitive data in SAP, they want to be able to know for sure that the data access is granular enough on an item-based level and also on folder-based, so that they can do like AD groups to folders. So that's what Azure Data Lake brings to the table, and that's, in real life, that's what I've seen. Of course, my view might be very limited, but that's what I've seen. Cosmos DB, specifically document DB, but there's MongoDB, and there's table storage there as well, and there's the graph GraphDB that I haven't really heard anyone using yet, but I'm sure it's coming. And about table storage, has someone used table storage API in Cosmos DB? Hand up. Yeah, haven't either. Oh, there's one hand. Awesome, sir. That's because, sure, if you want table storage to scale globally, Cosmos DB is the way to do it. But if you don't, then it's just costly table storage. So there is a need for it, but it's very niche. And my hypothesis was that no one's going to raise their hand, but there is one very unpopular fellow there. So yeah, it's schemaless indexed planet scale JSON storage. And it's based on, and this is the only bit I will talk about Cosmos DB because there's a lot of people who've used Document DB, but to me it seems that these partitions, the difficulty of partitions haven't really been understood or they've been understood, but they haven't been maybe really felt. So I hate these partitions. There's two levels of partitions. There are logical partitions you can kind of control, and there are physical partitions you can't control. And Microsoft had to make it so that it's globally scalable, sure, but it's havoc on our regular-sized projects that need to be globally scalable because it's very hard to optimize that. As an example, we have a Document DB and you have a container there, that's basically a database. You define the size of the database, the throughput. Here it's 5,000 request units per second. And first off, don't think that's request per second. You might think it's HTTP request per second, but do not. Request unit is a unit of measurement that says that if you read 1 kilobyte message from Document DB with its Document DB ID, then it costs you 1 request unit per second. But in most projects, you never do that kind of query. There's always some kind of a where or join or you fetch it with different data. So it's always more than 1 request unit per second. So 5,000 sounds a lot. It's not. It's not a lot. So you have that container. There you have logical partitions. You partition your data with a key you define. You say, hey, let it be device ID. All with the same value go into same logical partition, meaning that they are physically close by to each other, making the query for the device data fast. What if you have a query for let's return all the data for all the devices for this tenant? If you have device ID, they're going to be in different partitions, and that will be a cross-partition query, which is slow and expensive. Okay, so you go with tenant ID, and you're like, hey, let's use this tenant ID. Then I fetch all the tenant data, and I get all the devices and everything from there. So logical partitions have a 10 gigabyte limit. So that might be a consideration why you don't want to have a big key. But another consideration are these physical partitions, which really annoy me. I understand, still annoyed. So, you might have 5,000 RUs. It might have 10 physical partitions. In this example, I have 5 physical partitions. If you pay for 5,000 RUs, you get that divided by amount of physical partitions, and you can't define the amount. So in this example, you have 1,000 RUs per second for this physical partition. Now, let's play the role play. We have tenant ID, a big, huge tenant. All of that data is in one physical partition, and they make a lot of queries at a time zone when nobody else does queries. So all of those queries go to one logical partition that is in one physical partition, so it's limited by 1,000 RU per second. What about the other 4 physical partitions that you pay for? In the tune of 4,000 RUs per second, they don't do nothing. They just sit there, no queries going there, there's nothing there. So this one part of your app is throttled by the physical partition, and the rest are unused. So the only way to make this mathematically effective is to have like thousands of keys. But if you have thousands of keys, then it means that in most business cases, you need to make cross-partition queries, which are expensive. So there's really no way to do a complex case in a very cheap manner. Of course, global scalability shouldn't be cheap either, because the other cost is that you would put it, you would have your SQL clusters everywhere. So I totally realize it, but this is kind of hidden. If you read Microsoft documents, you see examples of them using, hey, our partition key is LAX. It's all the airports in the States. What, a couple of hundred airports, or a couple of thousand, or whatever. Not enough. So in their examples, they have these keys that might not be distributed in an even manner between each other. Like LAX probably is a lot more hectic than some, rural Ohio airport that has one guy flying his drone. I hope the rant didn't come through. I'm a bit frustrated sometimes. So let's check out the demo. Event hubs and storage. I need to, oh, there it is. So what do we have here? We have this thing. I've been sending messages every 50 milliseconds. I'm going to show you what it is. The messages are the two types that I referred to earlier. I have a mouse. I have no visibility. I have a visibility. There we go. I don't have a zoom. It all broke? Oh yeah, no, I don't have a zoom. So basically, we have two messages, temperature type message that says type, temperature, device, and the temperature, 36.9 degrees there. And we have event message that says device, type event, event ID, 39, and event value true, false. So that kind of, something's on, something's broken, something's not. And these are surprisingly real life compliant. There's a lot of machines that send like true, false on events, and then there's same event when the value changes. So those we receive a lot of, and now we are checking. This is my event hubs. When you pin it to dashboard, it says untitled namespace overview blah. So if you do that, you find it with that name. So we have event hub here that's receiving messages, 20K, 40K. This morning I put this on like an hour ago or something. So it's receiving messages, and the nomenclature, the naming convention of event hubs, it's pretty groovy since it's an event hub. It's event hubs that contains event hubs. So these are event hubs, and this is event hubs. So it's a bit of an exhibit A thing, but still. So we have two event hubs in our event hubs. We have these data lake events and demo events. And my demo is about showing the capture functionality of the event hubs in those. I'm going to show how you configure the capture. So this is the event hub. I'm actually going to show you the other one so you can see an example of consumer groups. We don't have time later to come back to this event hub. So demo events, you open the specific event hub in the event hubs, and there's not a lot of, you can see not a lot of properties here. If you're familiar with Azure, there's the basic settings that are in every product. So there's only really like consumer groups and capture that are somehow different from other Azure products. So consumer groups can be seen here. There's data coming in, cool. There's analytics consumer group that is being consumed by my Stream Analytics demo, and there's persister functions that are being consumed by my Azure Functions demo. You're going to see those later, very, very fast. And then we have this capture feature. It's just here. I have two event hubs because you can only have one capture in an event hub. And here you simply select where you want to capture the thing, Azure Storage or Azure Data Lake Store. And in this demo, I'm going to show you both because I'm going to talk a bit about Azure Data Lake when we get there. So let's check out the blob storage. It's here. Oh yeah, now I don't have Zoom working. This demo is gonna, oh my God, this is bad. Basically, what it does is that it puts the demo events, I'm gonna talk you through because you probably won't see. So there's demo events named blob that has these folders according to partitions. So partition 1, 2018, then I'm month 1, and then 18th day, and then like first minute, and then first hour and then 11 minutes, and then it has this Avro file. An Avro file is Apache Avro. It's an open source Apache license binary format, and it's very easy to manipulate it. You can find the packages from NuGet. There's Microsoft.hadoop.avro that you can use to manage this, and there's Apache.avro NuGet package as well you can use, and all of that. So you don't have to be worried, but it's binary, so we can't really see it with this kind of tool. You need some tooling to read the things you capture, but that's okay, because they are in so cryptic place anyway that you won't find them. Yeah. You can. That's cool. We won't go back there anymore. Thanks, man. So now we are in data lake. So data lake, I won't go through the basic features, just gonna click Data Explorer up there. And here you can see this very Windows-like foldery experience. And before we go see what kind of data capture throws here, we're going to speak a bit about the features of this POSIX access. So I clicked Events, Folder, and now clicking Access. And now here I have access for myself, and then from Microsoft Event Hubs it has read, write, execute. I can press Add. And then I'm going to configure a user or group. I'm going to look for Microsoft. So here Microsoft found like Microsoft Event Grid and Microsoft Service Bus and Microsoft Event Hubs. So you give access to those type of things. And then I'm like, oh, I'm going to give I'm going to give Sami Lavikko access. So I found this user, and there's Sami, and I can give him access to this folder. So let's do that. Let's select Sami, and then we are like permission read, write, execute this folder, and all children, and stuff like that. And it's the same for those files you're gonna see soon. So that is pretty handy, and of course that's totally like API manageable and all of that stuff. So you can really go to woods with making a secure, beta level storage and Terra level. So, data lake events, partition 1, this year, why is it all, I don't want to, and I don't want this to be, oh yeah. So there are these empty, when I'm not sending messages, there's this empty 500 byte file that is still stored by capture in these locations. These are still Avro files. I wanted to find some file that really had stuff, because this data lake knows how to open the Avro file. But unfortunately, I'm afraid it might take, because we are pressed for time with this. This is really a 1 hour thing I have here. So 45 minutes, I don't have time to find it. But let's rest assured, Azure Data Lake can open Avro files. There's a bit of that binary, because it opens it in ASCII, but you can still see the values the messages have when they've been captured. And that was Azure Data Lake. It's pretty interesting tool, and something that, since the pricing point on Azure Data Lake is kind of the same as Azure Storage. It's like 30 euros a month for a terabyte. So, sir. No, that's a good note. It doesn't scale, and there's a bit of a performance difference. Azure Storage is slightly faster. In our tests, it has been slightly faster, but not to the point where you could think that Data Lake is like cold storage. It can still respond to queries. And of course, with files that are over 5 terabytes or something, it is faster because it reads from multiple locations, and Azure Storage doesn't. But still, it's like if you are using Azure Storage, go to your project and think with the theme. Okay. Do we have some benefits we could gain from Azure Data Lake since the price is the same? So business people will be like, sure, yeah, do whatever. So let's get to process. Functions versus stream analytics. Functions are great when you don't need aggregates or time functions. Sure, you can do those. You can do anything with Azure functions because it's just code, but you just need some interim storage and stages and all of that stuff. There's good routing, not yet to Azure Data Lake though. So there's basically, you can plug in Azure functions to many different products or tools in Azure. It's IoT Edge capable. We're going to have Eldert, you're going to speak about IoT Edge tomorrow. You have some bits about this, I'm guessing. So you're going to hear more about IoT Edge tomorrow. And it can be bound to Event Hubs direct and to IoT Hub via Service Bus. So IoT Hubs, like I said, it doesn't support routing to Azure functions. And about Event Hubs, what it does, what is interesting here is that it exposes a partition to one event processor host at a time. So if you code an event processor host with C#, it will connect to, it can connect to multiple partitions, but partitions will only send messages to a single partition. And this is meaningful because of ordering. As an example, here we have 4 partitions in this Event Hub, and there is one Azure function listening to all of them. At some point, that Azure function is like, oh my God, I'm full, so I need some friends. It's gonna create a couple of friends, and they will listen to partitions and handle the things. It will never do like this, so one partition won't send messages every, round robin to 2 Azure functions. What this means is that if you want ordering from a device, you want to get the messages in a certain order from the device, the order is meaningful, you have to force partition sending to device so that, hey, I only send from this device to this one partition, but then you can rest assured that all of those messages will go to Azure function that is reading from that partition. So in Azure function, you can be sure that, hey, this is the guy that receives all of these, and you can process them subsequently and store or do whatever with those. If you don't need ordering, then for performance reasons, do not define the partition, and your Event Hubs will be cheaper because it can maximize the resource use. But this is something that's good to keep in mind. About stream analytics, it's great when you need to create aggregates from continuous telemetry. It's got this SQL-like language for doing aggregates, sum, average, count, grouping. It can recognize time differences between things. So now was this event, now was this event, and the next time there's change in the spacing between these events. Is that meaningful? I don't know, but it can recognize that and tell you, hey, this happened. And also absences. You are receiving heartbeat from a device, now. It can tell you, hey, there's an absence. And then what's the basis of the stream analytics, this aggregate thingy? It's windowing. There are 3 different types of windowing functions there. There's the, and these images are from Microsoft documentation. These are the only ones, but you can find these. So basically there's this tumbling window at the end, 10-second interval. It's gonna return you the count of tweets per time zone. Then there is this hopping window that's you're gonna define the window length and when it starts, basically, so that you can have overlapping windows. Otherwise the same. This guy will return from the last 10 seconds, updated every 5 seconds. Every count of tweets for a given topic. And the last one, the most kind of interesting one, is the sliding window that activates whenever there's an event in that window. And the having is interesting because with that you can define a benchmark or a limit or I forgot the good word for that. But basically you can define that, hey, only activate this sliding window whenever that parameter comes true. So, hey, this is, for this period, this is activated when there's a sale of this amount over this amount or whatever like that. Whenever there's a temperature that is over this one, then follow the temperatures around it or whatever you can figure. So this is pretty nifty. Demo 2. So let's go back to Azure portal. And we're going to look at let's look at the temperature job first. So this is the stream analytics thingy, and it's very clear. You define an input. Temperature input is from Event Hub. You just give the Event Hub information there, nothing else. Then we have the output, temperature out. It's to data lake store. You just give data lake information here, nothing else. And then you have the query, the magic that happens between those. I hate that we don't have zoom. Do we have zoom? No, we don't have zoom. I don't know where it disappears when I do zoom. Well, so basically we have this select. We are selecting device ID and temperature with average. Into temperature out, data lake, from temperature input, event hubs, where type is temperature. We had two types of messages coming in. We had event and temperature. Let's just check out the temperature events. And we group by device ID, and we have a tumbling window of 30 seconds. So we basically calculate the average temperature for a device every 30 seconds. That easy. What is that, 12 lines with a lot of spacing. And what's the result? Whenever I find my mouse, I will show you the result. There we go. Oh, nice. So let's check out the data lake store and the data explorer. And here we have the Azure, and the date, whatever. Like, there's a big file. So here we have the result. It's just device ID 82, device ID 104. I have two devices in my test messages. So here is the average count. There, third line, maybe you can see it's 36.8 average temperature for 30 seconds, meaning that maybe that crosses some boundary. Maybe something should be done. I don't know. But easy tool to do stuff like that. And then we are going to check out the Azure function app. So a serverless thing, and it's the same. We have input, we have output, we have some kind of function in the middle. Let's wait for it to load. So we have here in the integrate, we have a trigger, Azure Event Hubs message from consumer group persister functions, and output into Azure table storage. Return value is put into table events. And here is the query. Basically, it gets the message. I take the string message and I put newtons of JSON there, and I just deserialize that into object. I use dynamic keyword because I don't want to define the object. What I've defined is table message, meaning that it has partition key and row key, very familiar to most of you on table storage. And then it has the message as a JSON. So as a string, JSON string. So why do I want to have an object? Because I want the partition key and row key to be meaningful. Here my partition key is device ID and the event type, meaning event or temperature. And then my row key is date time offset. So epoch time for, Unix kind of from 1970s in milliseconds. So it can be, it's nice for sorting. So what do we have here? Oh yeah. Sami sanoi, että tätä pystyy zoomaan. Zoom in. That's awesome. Maybe people can see. So I'm in events, and you can easily see that now this is the same as capture, right? Basically, we are storing everything, but this data is semantic. It's meaningful. You can use this data for something. You can define the partition key. You can define the row key. You can do things. With the capture, you get this folder structure of partition and then the timing. And if you have all of the data coming to same partitions, you don't know what's where. But with this, it's queryable, it's searchable. So you don't only get an archive, you get a usable archive. And that's meaningful. And then the last slide. Storage, we spoke about this index requirements. If you use table storage, be sure that you don't have more and more index requirements, indexing requirements, query, complexity requirements coming in. Otherwise, it's great. And Cosmos DB partition scaling, I spoke about that a bit, maybe too long. And also Cosmos DB data types. For example, date times aren't good in Cosmos DB. Go with epoch time. I just showed those milliseconds from 1970 because that's natively like Cosmos DB very strong at indexing ranges. So it responds faster to queries if you do sorting or something with these than with date times. Performance, if you have real-time requirements, don't start doing the work when the HTTP request comes in, of course, but think about moving part of your workload into this IoT pipeline, into those processing events, into Azure Functions or into Stream Analytics, and then just cache those results partially or fully in Redis. Stream Analytics performance, it's great, but it's sucky. So Stream Analytics performance is surprisingly low in a sense that, okay, sure, it can process a lot of events, again, if you put money in. But what you shouldn't do is route everything through Stream Analytics. So just route part of the messages you receive. Just route the messages you want to time series aggregate on, and nothing else. Otherwise, it's going to be expensive. Something on IoT projects you can't really work with. There's some device, you shoot the device in the first slide, that is somewhere in the world, in Brazil, and there's a maintenance guy who goes there every 3 months, and that's a time window when he can update something. So you're like, hey, we need a heartbeat so we know if this thing is online, because the UX guy, he drew an online thing there so that, people want to know if this device is online. And we don't know if it's online because we don't receive heartbeat from it. And then the maintenance, it goes down the organization, and the maintenance guys are like, well, we're going to go there in 6 months, and then it doesn't work because it's some kind of assembly code somewhere and it's broken. So this is just, most of us are used to working with large, meaning usually quite slow organizations, but this is something that will make your hair pull out when you are working with real-life devices installed in 1930s. And then the last bullet, and also the hardest thing, the IoT projects will not fail because the pipeline I just showed, right? Just technology, couple of tools, nothing special about that. Modeling the asset, this is the difficult part. The manufacturing device or equipment you saw, that might have hundreds of sensors. So you get an error from one of those. Is the machine unavailable? Is it broken? Does it work? Is it doing it's supposed to be doing at that factory as it is? Maybe it is, maybe it isn't. The thing with modeling that asset is that, hey, these 3 errors together cause the machine to be unavailable. But these 3 errors together, they're just minor informational thing. There's some light is broken, maintenance people will have to use their lamps or something by themselves. So modeling the asset, if you receive hundreds of events, that's the biggest job, that's the hardest job, and that's what projects are really always about, communication with the people who really know the device, really know the domain. Done.